Hello, our project is Scalable Modeling for Adaptive Real-Time Trust-Based Communication. I am the PI, Iftekharuddin from Old Dominion University. We have four other co-PIs from Old Dominion and University of Virginia. And we have been working with our community partners, Kyle Spencer from City of Norfolk and RISE, a nonprofit organization here in Norfolk, Virginia. So the project involves four tasks, like you see on the left-hand side. So the first task is real-time learning of flooding, recurrent nuisance flooding information, RNF. And then the second task is about physics-based modeling for prediction of this flood information. And then these two models will feed to task 3 and 4 for traffic flow characterization and risk communication. So we'd like to take this information and be able to communicate to the drivers for action and their planning. The vision involves for this project is to develop this scalable modeling and trust-based communication system for the roadway inundation detection and monitoring. And we'll evaluate this system in a flood-prone area in the city of Norfolk using the data that is going to be collected from city's camera and other sensors. The research is, of course, inspired by the user case, in this case, the flooded streets in the city of Norfolk. And the plan is for us to collect this data for automated and real-time detection of the extent and depth of the recurrent nuisance flooding, and then real-time communication in collaboration with the city of Norfolk. The fundamental contributions that we propose is to come up or develop with real-time learning models for street level depth and extent of flood recognition, and then also improve the community scale road network flood prediction, and then improve the microscopic car following models, and finally effective risk communication about this flooding information to the drivers for their planning. So in this project, we have made some good progress, at least in 3 areas. The first area here is generating synthetic image data. Of course, we are also collecting data on the street level, but for us to be able to build a huge database, we need to also collect synthetic data. So we're doing the 3D modeling, like you see here on the left-hand corner, with the 3D models of the city. And then we are also taking all these data and building fully connected deep networks to process the tire and the information based on the tire. We're going to obtain the height and depth of the water. In addition to that, we're also generating synthetic image data, like you see in this video on the left, bottom left corner. So this will be a realistic synthetic data flooding on the streets and also the cars moving around, like you can see. So we are trying to make this more rigorous using physics-based models. The second area that we made some progress is this physics-based prediction models for flooding, both at the city level, driven by the nuisance flooding, and also at the coastal level with coastal hydrodynamics models. And we're taking these models and making some approximate models using machine learning. And in one case here, we got about 3,000 times speed up compared to the physics-based model that we already have. The plan is to bring these two models together and come up with acceptable machine learning model for flood prediction. And the third area that we made progress is in the risk communication area. So this is an experiment that we are doing with simulators, driving simulators, with 4 different types of flooding information: no flooding, flooding, and some smaller amount of flooding on the street. And then we have 136 subjects, and they are given these different scenarios on the left side that you see. And it shows the results here in the bottom in the chart. And it does show that when there is no flooding, of course, and the flooding, the differences between those two, and how the drivers behave in these cases. For the evaluation of the project, we learned that our plan to use cities cameras was not realistic because the city did not have access, actually did not have cameras in some cases for the area that we are looking at in the city of Norfolk. So we now plan to reach out to Dominion Power to get access to roadside electric distribution pole for power and mounting visual cameras for this project. Anticipated outcomes and success. I'm not going to read all of these. This is basically the plan for each of those 3 areas that we just discussed earlier, and then also hopefully work on some journal publications and conference submissions. So this last slide is just bringing together all these different aspects of this project we just talked about using the sort of quad chart matrix, starting with the 4 tasks and all the way to the fundamental research contributions that we just talked about. Thank you.